Da, 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 da. In the last video, we saw how this is going to end up with an F test, but I don't want to go all the way to how to do that right just yet. I want a whole video on some of the pieces. That way, when we put it all together, it doesn't seem so daunting. So we want to look at our data sets here, and we have a bunch of dots. We want a way to write specifically what each dot is. So this dot up here, he is group 1 first dot, so x1, comma 1. And then we have x1, comma 2, x1, comma 3, all the dots that are in this group. Next group, we would have x2, 1 for the second group first dot, x2, 2 all the way down. It looks like x2, 25, just eyeballing how many dots are in there. And then x3, 1, x3, 2 to x4, 1, x4, 2. Now we have a notation for every one of those x's. We also have an average for each of these groups. X bar 1 for the average of the first group, X bar 2, X bar 3, X bar 4. And if we lumped all the data together, we would have an X bar overall for all of it. So here's our notation we're going to use to keep track of all these pieces. What we want to look at is the variability between the means. How spread out are the red averages from the blue overall average, and also the variability of the data. How spread out are, for example, this first green dot from his average. So we want to look at the distance between the average to the overall average. That's going to give us variability between the means. We also want to look at his distance to his group average. That'll be variability of the data. There's a third thing we could talk about, how far from that dot all the way down to the overall average, and that's going to be useful later. We don't need that to make the fraction for the F test, but we're still going to talk about it because of reasons that we'll get into.
I want to know right now.
Okay.
So this red distance is how far from X bar 1 down to the overall X bar, whereas the variability in the data is going to be from X11, that specific guy, down to his average. And then the blue distance would be from x11 all the way down to the x bar. So a couple pieces that are common here. The x bar shows up 2 places. The x bar 1 is showing up 2 places. And x11, the data point itself, is showing up in 2 places. Let's do the same thing again for this data point down here. He's a different data point, so the red piece is going to be for X bar 4 out to the X bar. And here we have from that data point, which is X4, I think he's number 15, up to his average, which is the X bar 4. Or we could go from X415, that specific data point, all the way to the overall X bar. Let's talk about those red pieces first. This is called the SSG, sums of squares for groups. And you'll notice we're going to be adding up a bunch of things that got squared so that we can talk about how far apart the groups are. What do we want to do? We want to sum across. Here, this first sum from j equals 1 to n1, that's saying do it for every data point in the group. And then the other sum says go across and do this for all the groups. So we have x bar 1 minus x bar, that's the first group, and x bar 1 minus x bar because there's another data point in that first group, and then x bar 1 minus x bar because there was a third data point in that other group, until you do all of them. And then once you're done with the first group, let's do it again for the second group and the third group and the fourth group until we've added all of them up. Now you might be looking at that thinking, I'll bet there's a simpler way. I mean, notice this piece, x bar 1 minus x bar, and then again, x bar 1 minus x bar. How many of those pieces are we going to have? We're going to have as many data points as there was in group 1. So we can rewrite this instead of saying do it for each data point. Let's just do it once for group 1 and then multiply it by however many items are in group 1. And then sum that across all 4 groups. Makes a much nicer equation, right? It actually fits on my slides, whereas the other one has dot, dot, dot because it was just like way too big. The next one, which is the green distance, is going to be similar. This is SSE. Again, we're summing up things that were squared so that we can tell the error in the data. So sums of squares error. For each data point in the groups, across all the groups, what do? Take the data point minus his average. So here's x11 minus his average squared, x12 minus its average squared, all the way across for all the data points in group 1. Do the same for group 2, do the same for group 3, do the same for group 4. But it'd be nice if we could simplify it the way we did the last one. Well, this idea of xi minus x bar squared, that should ring a bell from something we did long ago, which was simply calculate standard deviations. Problem is, when we calculated standard deviations, we did sum up xi minus x bars, but then we divided by n minus 1, and we don't want that. So to simplify the equation, let's have those standard deviations, but multiply by n minus 1, and that way we don't have that denominator sitting in there. And that's just going to be the sum of each data point minus its average squared. Notice that we're using s squared, so that's not standard deviation, that's variance. That's why we don't have to worry about the square root that was part of that equation, because the squared gets rid of it. The n minus 1 is going to cancel out, and this will just give us this sum of squares. And then we add up across all 4 groups. So again, we get a nice, pretty equation that fits on my slide with all 4.
This is so nice. I wish it could be like this all the time.
I do the variances of each times by their sample size minus 1. Great, there we go. What about the last one? The guy that I said we aren't going to use for the fraction, but he'll be useful later. This is the SST for sums of squares total, the total distance from that data point to the overall average. And we could add all these up, same as we were doing before, right? Go across all the data points in all the groups. Is there a simpler way to write it? And the answer is yes. It turns out this guy is just the sum of the other 2 equations we were looking at. And if you remember the picture, that might make sense to you, right? From the data point to the average, and that group average to the overall average is the same as from that data point to the overall average. Turns out it's not that simple, because a squared plus b squared doesn't necessarily equal c squared, but in this case it does. It's specially made to. If you want to burn a week, go prove that to yourself. But this is a very nice equation. If you can figure out the other 2 guys, you can get this one easily. So there's 3 really important pieces to making our F-test. This slide summarizes them. We have our SSG, SSE, and SST. You can do it by data point individually, or you can use these simpler equations that are based off the averages and the standard deviations. And notice some common pieces. X bar shows up in these 2 guys here, the X bars for the groups, the overall X bar showing up here in these 2 equations, and then the individual data value showing up in those 2 places. Now we're ready for the next video where we're going to try to put it all together.